I can't see you, but you can see me, so that works out. So let's get started. I'm Tracy. Been at Microsoft for like 17 years. It's kind of amazing to think we've done that, worked on various products and offers. And Torsten will be joining me up here for some of the demo work that we do. The thing we're going to talk to here is do an overview of SQL DB, and that's what I'll end up calling it. You know, its official name is Azure SQL Database. It's a little long for me to say that over and over. So we'll call it SQL DB. And probably a unique thing about me is, I guess you'd say the last 3 or 4 years, the SQL Server 2014 effort and our SQL VM effort, I kind of led both of those efforts. And the last year or so has been on SQL DB. So I have a pretty good perspective of the whole range of what we produce and how we produce it. And so one of the things, if you guys were in one of the breakout sessions yesterday, they talked about cloud first. And Satya has his definition of cloud first. And then I think we have internally our definition from a development standpoint. And when we think of cloud first from a development standpoint, it's really having a single code base that we use for all the SQL offerings. And then ultimately the goal is to deliver features and functionality first in the cloud through SQL DB and then through our on-premise offerings. And at first when we said that to people, and even within the team, they're like, well, wait a minute, that's kind of weird. How do we think about that? And the reality is, if you do it that way, you get it out to customers sooner, it gets tested at scale much sooner, and it allows the team to operate much faster with better communication versus spending 6 months to a year working on something, giving it to some customers in a CTP, then finding out a year or 6 months later of what worked and didn't work. So this is kind of a philosophy that we have going forward now within the organization, and actually has been super, super impactful. And so we think of that across the 3 main deliverables, if you want to think of it: SQL Server, SQL VM, and SQL DB. The quick overview of SQL Database, how it's different than the others, right? It's a PaaS service, a platform as a service for SQL. You don't have to worry about updates. You don't have to worry about security fixes. You don't have to worry about the hardware. You don't have to worry about any of that stuff. We manage all that on our own. And this has been a big transition for our team. If you can imagine, you know, if you talked to me 2 or 3 years ago, my whole job was how do we build SQL Server so that we could deliver it to customers and they could install it on their hardware. The reality is, the only way we knew how they used it is by talking to them. We didn't run it ourselves. So the transition on SQL DB is we are running SQL Server as a service ourselves. And that means we have to understand all the details. We buy all the hardware. We do all the capacity management for it. We do all the security, all the updates. So that's all handled for you. And then the promise to you, the customer, is 4 nines of availability. We have a whole set of series that I'll walk through, price points and performance that we offer, and that it's being secure along the way. Some fun facts, just to give you an idea of my point of the scale that we go at. We have a customer that creates 60,000 databases a week. You know, think about that for a minute, 60,000 a week, and then they drop them back and forth. We have another customer that has 114,000 total. Now, there's always this mix of dropping and creating them that goes through that. We run in 133 countries in every one of our regional centers. We get 350 million logins a day. We have 1.4 million customers as of last week, and that grows substantially, so that could be off a little bit. And then what we really do is track things by hours, database hours that are used. And it's about 20 million database hours per day, if you go through that, and growing at a pretty phenomenal rate. And so these are things just as a fun facts aspect. The other thing is, because we run this as a service, we know what's going on in the back end. We know the growth, we know the usage, we know where we need to apply resources, where we don't. And it's actually just a phenomenal change in the way we do business in this aspect. So the other thing we look at is carefully is what customers are using it and what are they doing with it. And we kind of broken this down into 3 main categories. And if you look at the left, it's what I would call the ISV or SaaS provider, in particular ISVs converting to SaaS. And this is a super popular offering for them, and you'll see some functionality of why later on. But if you just took this model, you're an ISV, you used to deliver your application to companies, It was backed by a database. Effectively, that translated into your application, and a database was being run on each and every customer. The minute you change that to a SaaS application, you now are running the application and all of their data in their databases in an environment, and you have to manage it that way. And so the customer doesn't think about it. Effectively, the same thing as what SQLDB is, us having millions and millions of databases that we have to manage and maintain, whereas before we didn't think about it. And so that whole environment has some unique challenges and opportunities of the scale that you can grow to. What does success look like? Do you have hundreds of thousands of databases, and how do you manage that in that environment? And then what's the pricing of it? And so we'll talk to that in the second half of this in a big way. And so you'll see some new things that we're really tackling in that audience. The right two tend to be a little bit more enterprise focused. And what we mean by that is there's two categories we look at it there. The enterprise apps serving their employees and the enterprise apps serving their customers. And there tend to be very, very different people working on them and tackling them accordingly. And we have different examples of both of those. The thing I would say more than anything is the right two columns tend to be more predictable in the performance that you need, the load that you need, in general what's going to happen. The left side is very, very unpredictable because you're dealing with customers' databases and what their demands are. And so we have some work in here, and we'll show you how we make the unpredictable predictable, and how do you count on that accordingly. So here's an example of it's an insurance company. So insurance companies tend to be some of the most conservative companies in the world. But their business is changing in a dramatic way. And this is a company, Aviva, in Europe, that is traditional, has all their billing, all their monitoring, all that stuff on premise. But they have the idea that they wanted to, and you see several companies doing this, using a mobile phone, putting their app on the mobile phone and tracking your driving characteristics. Basically, are you a good driver or not? Are you following the law or not? And I always joke on this because it's probably not an app I would go get for me, because I don't think it would be beneficial to me, but I think to others it would be as lowering the rate as you go through it. The interesting thing about how they built this, they had all their on-premise work that talks about their quoting system. They wrote this app for the mobile phone, and all of the data that comes from all of these customers feeds into a SQL database. And they do that because of the scale is unpredictable and can be quite massive, and they separate it from their on-premise business. And then they tie the two together to determine what kind of quote they're going to give you, what's your estimate that they're going to give you on that way. The thing that's, I think, most interesting about this, they did this in a matter of months. They've been hugely successful with it. They've actually seen their business grow in a big way due to this. And this changed the way this company operated, right? They were very, very traditional, and this was a great way of connecting their on-premise and the cloud offerings as one. And so that's just one example of a company that modified their offering to take advantage of this. So we as far as the SQL database, we have three tiers: basic, standard, and premium. And the simplest way to think of these is they're really performance and resource driven. So basic is designed for lightweight transactional loads. Standard is for your more typical loads, and the premium for your high throughput loads. And so the differentiator, performance, and you can kind of see by the dots here, basic gets a little bit, standard has a range, premium has a range. And you'll see, I'll show you an upcoming slide that shows the offers that we have. But the things that are in common is the programming surface area across them, the availability across them is the same, and the elasticity is the same. And the reason is, and this is different, if you're familiar with SQL Server, historically we've had Enterprise Edition and Standard Edition, which meant Enterprise Edition got some more high-end features that cost more, and that's just, and the limits were higher. Well, in this business, particularly when we think of the SaaS provider, you can think of two cases. Say you had a large company that had 5 very big premium databases. They're very expensive, they're very performant, they get the customer what they want. Let's say we've got another customer with 100,000 databases, and the 100,000 are all smaller databases serving their individual customers. When they come to us, could you imagine the story I would have if I said, hey, only the good features are in premium, And I understand you have 100,000 databases, but we're not going to give you the good features. Security is not going to be for you and some of the other things. It would be a nightmare of a story. So you'll find in SQLDB, in particular our cloud offerings, we've changed our business model in this way. It's the same features across the board, especially if they can run on the performance level that we have. And so the differentiators are performance and storage. And that makes sense from a customer side because that's what costs us money, and so that's what we pass on from that perspective. So it's a very simple model, but it's different than what we've done in the past. So, and all of this performance is based on this thing called a DTU. And if you watch, you'll do a little animation here. And DTU is made up of compute, memory, writes, and reads. Now, I will say, the biggest thing that comes from people that are on-premise, first coming, they're like, I don't get what a DTU is. I need to know exactly what the formula is so that I can predict how much I have to pay. The interesting part is if we talk to people 6 months after they've been using the system, they never ask that question anymore because they realize they no longer don't have to worry about what the hardware is. They don't really have to worry about what the capacity is. They just need an environment that they know that their system can run in. And so the next slide talks about predictable performance in these offers. So B, as you see down here, is a basic. It gets 5 DTUs. And you could be going, well, I don't know what a DTU is, and that's fine. It's a combination. But you can run an S0, and I know I get twice as many of those as I did in basic. And then you work your way up. S1 is 20, S2, S3 has 100, premium, P2, and then a P3. And we'll be introducing some other ones out shortly that will actually be larger than that. The reality is, once you've run the system, and here's the other thing that's nice about it, this is a pre-contained set of performance for your database that you can create in minutes, and Torsten will come up here in a second and show you that. But you can also, the trick is you're not fixed. So say I created an S0 database, and I ran my application against it, and I found out it wasn't performant enough. I could upgrade it to an S1 or an S2 or any of these in actually a couple of minutes, and then find out right away if it works or doesn't work. The thing is, if you were on premise, you would think about what hardware I had to buy up front, what were my estimates, what was my load, all these things that you no longer really have to think about. You can choose it very much in a more dynamic way. So I'll have Torsten come up, and we'll walk you through just creating a database, and you'll get a sense for how quick and easy that is.
All right, good afternoon. Turn on my mic. All right, so good afternoon, everybody. So what you're seeing here is the Azure portal that I'm logged into with my subscription. And creating a new database is really straightforward. You click the new button down here, go into the data and storage section, and then here's SQL database. Let's give the database a name. Let's say it's DemoDB01. Let's pick an existing server. It's basically the container where my database lives. And I have one down here. Let's use that. Blank database is OK. This is the pricing tier is the different variants that Tracy just introduced you to. So you see the basic one down here. You see the 4 different standards here, and you see the premium tier up here. For now, let's pick the premium here. Say, OK. This all looks good.
And what does the server do for us?
So the server is basically a logical container of databases. So I can create many databases in the same logical server. And the server then helps me to manage, for instance, security. So I would create my logins and users on the server. Also, the firewall is configured at the server level. And then all the databases that I put into the same server can use the same logins and are benefiting from the same firewall settings. Okay, good. So we have the database creating here, and with that, back to Tracy.
Yeah, and so it goes to this point of it's really a matter of minutes. And the other thing that we should highlight, he created a P1. Where did you create it? North Central? I think north, central, middle of the country. He could have picked just as easy Asia, someplace else in any of our regional centers. And that's a 4.9s database that'll be up and available. He'll come up here shortly, and we'll talk about how we can do some more advanced functionality on it. And again, the other thing, the one he created was a P1. We could just as easily, if we had time up here later, change it to be an S1 and just lower its cost, and away you go. Your application will be running against it, and you just have a performance difference and a price difference. Let me, that we just did. So the other thing that we introduced, and this was in February of this year, the new version of SQL DB, which we call V12. And basically, effectively what it was leveraging off of the SQL 14 and the SQL 16, 2016 bits as the underlying architecture, so that we can get better support for large databases. The programming surface expanded in a big way, so you get full text search, CLR, things that you can see there on my list. We improved DMV support, so you get better understanding of what your system is doing, what the load is, and the telemetry associated with that. And then we actually added better performance. And so, for example, the premium database that Torsten created was 100 DTUs two months ago. Now it's 125 DTUs. Now the benefit to you as a customer is the price was identical. And so we kind of have, in general, this model where we want to have our price points and then increase the performance over time as we can monetize newer hardware that's faster and cheaper as we go along that line. So there's a lot of benefits that came with this. It's actually been growing like mad from a business perspective, and customers are super, super happy with it, particularly those that were SQL customers before, because the connection of the dots is much closer in what they can do and what they can support. And so that you'll see is called as V12. The other thing that comes in is security. And so security is always the thing that people worry about when in the cloud, and particularly with their data and their databases. And this is a big area that we've been investing across the whole platform. And there's a couple interesting things here. So TDE and row-level security are both in public preview right now. Auditing and dynamic data masking came out late last year. And I'll use the first two as an example, and I'll actually use row-level security. And you'll see this in a demo that Torsten will show you later. This is a great example of cloud first, because row-level security has not been introduced into the box product yet. It will in the upcoming CTP and the release of it. But this we released a month or two ago in public preview, and then we've already got a bunch of usage on it, and then it allows us to harden that before we deliver it through the product in the end. And the nice thing is we can public preview things in the cloud. Customers can opt in, try them. Once it's solid, we'll make them generally available. And then that will match up very much in line with what we do in the box product of put it in a CTP and then eventually in our RTM of the box product. So it's a great example of getting a sneak peek or an opportunity to use some of the functionality ahead of time. The other thing people worry about is data protection. So how is it backed up? What can I do with it, et cetera? And we kind of have two forms of it, if you will. We have their disaster protection, and you kind of have the geo restore option, which just allows you to get it back, or we have the geo replication option, which means you're actually replicating the data into another region of the world. And we'll show this in the demo coming up. And you find that you can do this in a matter of seconds to make this happen, which is kind of mind-boggling when you think about it, because when we talk to folks in enterprises that have historically done this through our box product offerings, these are the things that you planned for and you took weeks to do, and you had to figure out where was the hardware, how was the connections going to be, how are you going to configure it. And you'll see this. It literally takes seconds to make this happen. The other thing is in our backup or oops recovery scenarios, we have a couple things. We have point-in-time restore, where you can go back and any point and click something back. And the same is true if you accidentally delete a database. So these things we have in there for our secure methods so that you are protected. Okay, so let's come up and show you geo-replication. Torsten will do his magic.
Magic, let's see. So let's switch over.
Oh, I got you.
So back to the portal, what you're seeing here is the database that we just created. And it's also here as this icon on my start screen. And as you remember, we created this as a premium database. We see that here, so the pricing tier is mentioned there. As Tracy was pointing out, we can change that at any point in time as necessary. An aspect that I just want to stress again is the fact that when you're doing these changes to the pricing tier, the database stays available. So your application will continue to run without an outage on top of it, which is quite neat. Coming back to the geo-replication aspect, configuring geo-replication is simple through the portal. I'll just want to walk you through the steps to get this set up. The little blue icon here with a check mark is the place where we've created the database. That's the data center in which it is running. And we can use any of the regions or data centers that we offer where we have SQLDB as the location for the geosecondary. We have certain preferences or suggestions. And the little purple icon that you see here is the preferred place, and I think that is South Central. Let's go with that recommendation. And it has to be, again, a premium tier database. We can actually read from it if we wanted to. And we have to pick a server that lives in the data center. Again, the server is that logical container that contains the databases for you. So I've just picked a random server that I had lying around in South Central US as the target for the secondary. And let's click Create here. And what you see is that basically the initialization process, the seeding process, has started for the replication here. And as soon as the process is going on, you will see basically a percentage number that shows you the progress of setting up that geosecondary. And that's where we are right now. And within the next couple of minutes or so, since we have no data in that database, that process should actually finish.
So again, it carries on that point. Create a database in seconds in a region of the world that you want. 4 nines availability, you can adjust it up or down, and then you can actually replicate it to a different part of the world in seconds as well. And again, for those of you that have done this sort of work before in an on-premise environment, you can be, I guess, equally amazed at how quickly that is, because it's a very complicated process to go through otherwise. Yes?
Can you talk a little bit about the failover and disaster recovery capabilities of what you just showed?
Yes. In what? I can't see anybody.
Yeah, sorry. How do you connect to it if it fails? Is it automatic? What do I do if that primary copy fails?
Yeah, it's automatic because it has a connection string, and so the logic is all in there. So you don't even have to worry about it. It's seamless for you. Yeah. See, now I'm going to switch to, so everything we showed you to this point was these contained, these singleton databases. They have a certain set of performance, they have a certain set of size, they have a specific price that you pay for it. And so I'll use an example. An S0 is $15 a month. You're going to pay $15 a month if you use it a little bit or you use it a lot, but it's within a container that you have. And that's great. And then each of those have their own price point. And that works great for predictable workloads that you can know exactly what they're going to do and when they're going to do them. The problem is if you're a SaaS provider and you have thousands of applications, odds are they peak at various different times of which you don't have control over, or the scale is such that you couldn't manage it. And so what would you do in that case? You're really left with, in our current system, you're left with 2 choices. You can either over-provision and buy the largest databases to meet your peak capacity that they're going to need, which would be a little expensive, or you can pick something lower, which is odds are when that application does need to peak, it's not going to get the performance it needs, which is going to lead to a customer not being satisfied or the application not doing what you want to do. So we've created this new model called the Elastic Database Model. And this was just announced late last week at Build. and it's live in the system right now under preview. And what it is this concept of, and I'll show you a couple graphics to give you the point of it. You can almost think of it as a pool of resources, in our case a pool of DTUs and a pool of storage that you move databases into, and then they leverage those resources across each other. And so in this case, at preview, we have these 4 different size pools, and these are DTUs, so 200, 400, 800, 1200 DTUs. And then what you then have is a maximum amount that each database can use. And we've set it, and it's configurable, but the max is 100, and then you can set it down to be lower. Now 100, if you remember from our prior thing, is the equivalent of an S3 database. And so this first pool, the first one that we have out there is the standard Elastic database pool. And what that gives you is the capability for any one of those databases in the pool to go from an S0 to an S3 automatically based upon the need that it has. And it just uses the resources from the pool. And so the point of this is to give you a visual representation. You should be able to pack in a lot more databases in there, assuming that their load is variable. Now, if it's the case where you have, and I'll make this up, you have 100 databases and all 100 need to be fully utilized all the time, this is not what you would use. You would use you'd use the singletons because they would give you the best value and be locked in. The reality is I've yet to meet a single customer that has 100 databases that they're all used that way. I mean, the load is usually very, very dynamic and all over the place. So this kind of gives a visual representation. So we have these fixed singleton databases, S0 through S3 as an example. And if you notice on the top, we're just trying to do a graphic of the usage that's being applied to them, and I kind of loosely tie it to customers. Now, if you notice on the far left, it's got a big peak. The things, overload, by the way, database does not explode. I want to make sure that's just the graphic. It just gets heavy and it means all the performance would be slower across the people. So now let's say we took those 4 databases and jammed them into an Elastic pool. And we've got a maximum and a minimum that we can choose. The visual concept is this. Each and every one of them can grow from an S0 to an S3 based upon the requirements of the application. Now, and think about that for a second. Now, if you only have 4, you could probably manage 4 and figure out how you wanted to do that. But once that goes to tens, to hundreds, to thousands, there's no way you could manage that individually. And so you go through, and then it's meant to have this whole point where they leverage those resources, and in one spikes, it just uses the resources, and then it's done, and it moves on. And so it's a great way to provide the best of both worlds at massive scale. The thing about that is you pay for the DTUs. You pay for the pool that you want to share, and then you jam in the databases that you want in there. And we'll have Torsten come up and give a demo of that. And the beauty is you don't, as a developer, if you're a developer, you don't have to think about what the performance requirements are. It'll leverage it. If you're the DBA management, you don't have to worry about that. It's just in that pool, and so it goes through. So we're going to show you an example of walking through that.
Can you switch me over? All right, and I just left this blade open and running. I wanted to show you the result of the previous demo where we configured the geo-replication, and it has finished. So within a few minutes, we were basically able to take that database and stand up a secondary for it and implement business continuity disaster recovery. So really straightforward, really easy to do that. Now, going back to what Tracy just mentioned, I want to walk you through a couple of the Elastic database features that we announced last week. And I want to start with the Elastic database pools that we had been talking about. So here I have a server, and the server is, imagine powering a software as a service application where each of the databases is representing a store or a location for that customer. And we have about 30 databases in that server. And as you can see here, the different locations have very different performance requirements. So the pricing tier for those different databases is also very different. And basically, you have someone who is managing that manually, spending time on analyzing what the utilization is, and then over time adjusting the performance tiers and pricing tiers for those different databases. And that, depending on the number of databases that you have to manage that way, that can be quite an effort. So let's take a look at how we can make this easier by putting all these databases into an elastic pool. And if you have a server that has many databases in it, the first question that you will run into is, what are the databases that we should actually add into the pool? Which ones are going to benefit from it from a performance, but also from a cost perspective? In order to make this easier for you, we are using machine learning techniques behind the scenes that are analyzing the utilization of the databases over the last couple of days and weeks. And based on that, we are providing you with a recommendation of whether it's going to be beneficial for you to put a particular database into a pool or not. And that's what you're seeing here on this blade on the very right that I'm showing to you. On the right-hand side, there is this column that highlights the recommendation that we're making based on the machine learning. And we're also giving you statistics about the peak DTU that we've hit and also the average DTU. And you can see that the average is fairly low for most of the databases, but they all spike eventually, as you can see from the peak DTU as well. The recommendation here is that all of these databases should be brought into the pool. Let's go with that. And then the next question that you need to address for the pool is, how do I want to configure the overall capacity, the DTU and storage capacity for the pool that I'm putting my databases into? And we provide you a number of wizards to make this easier for you. The first one that you see here is basically taking the aggregate utilization of the databases that I've chosen for my pool, and it's plotting that as a graph and plotting the DTU for it. And you can see that the blue squiggly line here is the aggregate utilization. And you can also see that we have different options in terms of the DTUs that you want or can allocate to your pool. And you can see that based on the utilization that I have on those databases, 200 DTUs, the minimum, is just going to work fine. So let's keep that. So that's the first aspect. The second aspect that you need to configure is, how do I want to govern the capacity for individual databases? How much do I want to allow them to spike, or how much minimum capacity do I want to set aside for them? Those are basically two configuration parameters that we provide you with. And in order to help you with these configuration settings, we plot you a histogram of the utilization of the different databases. And you can see here that for the leftmost database, which is the one that peaks to the highest level, it can go up to a utilization about 70 DTUs, while a lot of other databases are fairly quiet or almost dormant. So based on that, I can pick a maximum DTU allocation. That's basically the potential that we're giving the database to spike up to. And I can pick 100, and we could accommodate all of the spikes that we have seen in our analysis of the utilization history. We can also go down to 50, and that would be throttling some of the databases that have been spiking above that number.
And when would be a case you'd want to do that?
So think about scenarios where it is okay to, let's say, throttle or pause some of the requests on the databases. You might have databases that are used at certain times, particularly during these peak times, for, let's say, background processing or batch processing of reports. And for some of those reports, it might not matter whether they're complete in, let's say, 10 minutes or 15 minutes. So if you're using this setting then to throttle these batch tasks, that might be totally fine for you. And then this is a valid setting. Was there a question? Yes, please.
So how does DTU gets evaluated or computed based on the application needs? Let's say an application needs 100 transactions or something less, 10 gigabytes of throughput for running some analytics. So how does these two application metrics translate into DTU to evaluate, okay, I need some 100 DTUs or 50 DTUs?
So the question was, how do the DTUs map to the application requirements around, let's say, transaction throughput, memory consumption, CPU consumption? So I think the best way to think about it is if you run your workload, and that's what I would recommend, you just basically take a test workload, you point it at a database in SQLDB, you run it for a while, and we provide you with counters, metrics, and telemetry that will tell you what is the DTU consumption of this workload that you have been running or that you are just running on that database. And based on that, you can see where you're landing. Are you maxing out the database? Then you might consider going to the next performance tier. Or do you have still a lot of spare capacity? And then you might be in a good place to actually go to the next lower performance tier. So that's I think, a very practical way how you could approach this. Other thoughts around this, Tracy?
No, that's exactly what I would say.
Okay.
Sorry, how would, I guess you may actually explain it, with the geolocation and disaster recovery and all of that, does it work the same way with an elastic database or an elastic pool? Like you said, each database to have that?
Go.
No, it absolutely will. And in fact, you'll have the concept of the pool being replicated across and going through that. And you'll still be able to do it at the individual database level as well. So some of those aspects we're still working on because we're in preview, but when we make it general available, we'll have that. But that's meant to be the goal of it so that you have the same concept.
Yes.
So how much should we read into the numbers like 10, 20, 50, 100? Is 50 BTUs literally 5 times the performance of 10 BTUs?
Yes, it is.
Yeah.
Yeah. So all of this really scales. So
It's-
if you think about the bounding box that Tracy showed,
Yeah.
really that bounding box expands by that factor.
The thing I want to clarify, though, we use the term performance and resources kind of intertwined. It's 5x the amount of resources on that boundary, which doesn't always mean your app will get 5x the performance because it depends on what your app was leveraging most of. So that's just the way you think about it. But yeah, that's exactly how they're defined.
So let's just stick to the default values here for the min and the max. Let's select those. And then let's take a look at the overall price that we are getting based on these configuration settings. So if I look at the number here, that pool, that Elastic Database pool, would cost me just a little bit below $500 per month. Now, and you just have to believe me when I'm saying this, the original set of 30 databases that we looked at with the performance tier configuration that we had for those 30 databases was about $2,000 per month. So given this, there's a big cost benefit for putting these databases into the pool. And we're seeing this for a large part of the customers and partners that we have been working with, similar price benefits there. Note that this includes the discount that you're getting because the pools are currently in preview. But still, once we go out of preview for them, if you compare this to the original configuration that I had, it's still a substantial cost reduction. All right. Now, creating a pool takes a little time. Let me jump into a pool that I had pre-created here to illustrate some of the additional capabilities and features that light up once you have put your databases into a pool. The first one that you might run into is the question, I have these 30 databases. They're basically powering the data tier of my SaaS application. How can I write and develop an application on top of it? Particularly when it comes to things like reporting, you might end up with use cases where you want to query across all or some of those databases that you have put into the pool. As part of the work around database pools, we have also been working on a capability that we call Elastic Database Query, which allows you to connect into a single database, submit a T-SQL query, but then have that T-SQL query transparently behind the scenes farm out to all of the databases that you have put into, for instance, your pool, and then get the results back into a single place, which is great for scenarios where you want to do reporting or you have existing tools that rely on just connecting to a single database through a SQL Server connection string, but then behind the scenes going across a number of databases. So I've done that for these databases that we have in the pool, and I've built a little reporting application on top of that. And now basically I want to test this application and see whether it is working. It gives me a view for a particular franchise owner of all the various different locations and stores that he or she owns. And I'm logged in as, let's say, a test user, Martina, and I'm looking at the report right now. The report tells me that Martina is supposed to manage 2 stores with a total of 32 employees. However, if you look at the list of stores that actually show in the report, we're seeing many more stores beyond the 2 ones, and we see different names for the managers show up as well. So something is not configured correctly here. Particularly, we're seeing results, we're seeing rows for Martina that shouldn't show up when being logged in as Martina. So one of the ways that we can solve and address this problem is to use row-level security, which Tracy already mentioned as one of the features that we have introduced to SQL DB, and that are also then soon coming out for SQL Server on-premise. And I want to use row-level security to basically provision security policies that allow us to trim down the set of rows that, that Martina can see when running this report that we're looking at right now. Now, this report, as I mentioned, uses the Elastic Database query, so it stretches across the 30 databases to compute that report. In order to roll out the row-level security policy, we would basically need to log into each of the 30 databases individually and apply the policy to each database. That's quite cumbersome. Something that is going to help us now is, together with the Elastic Database pools, we also introduced Elastic Database jobs, which is a capability that allows you to take a T-SQL script and run it against a pool, an Elastic Database pool, and that T-SQL script will then be applied in an eventually complete fashion against all of the databases that you have in the pool. So let me jump back into the portal, into the pool here. Let me log in. Here, forgot to do that. And look at the Manage Jobs capability. So basically, you have 2 places up here where you can go into the Elastic Database jobs. One is Manage Jobs for jobs that you have already created. If you want to create a new one, you just click Create Job. And what we are seeing here is, if I click on the first one, is a predefined job that I've stored here that allows us to apply row-level security to a single database. And here is the script that I'm using for it. What you can see is I'm basically creating an access predicate, and down here I'm creating a security policy. All of that is wrapped in some control flow logic to make sure that this little script works well also when we are retrying. Elastic Database jobs will mask transient failures from you and do retries for you. For instance, if a connection is failing for a couple of minutes, we will automatically retry. In order for that to work, we need those scripts to be defined in a way so that they work under those retry conditions. So that's the script that are going to be running against these 30 databases. Let me just, and I ran it earlier today. Let me just run this again, and you will see that basically the tasks, the little task per database task will show up after a couple of seconds. You can see many of them have already completed. Some of them are still running. Let's wait for the job to complete. Now it should have succeeded. It says succeeded. So very straightforward, very simple. Basically took us 10, 15 seconds with an existing T-SQL script to apply that against all of the databases. Let's go back into the report and see whether we're actually getting the right result when rerunning the report. And voila, we're seeing that Martina now just has these 2 stores that she's supposed to own.
Yeah, that's awesome. That's awesome. Thank you for listening. So if you think about the summary of this is application, SaaS app, database for each location, which translated to different customers. The pool method allowed them to put this in an environment where each of them could spike to their various needs, because he showed it to you at the beginning where they had all different price points, which was somebody's best guess at what worked for them. We're often probably over-provisioning to provide the performance for them. Put them in the pool, You saved the money. You probably saved about 50% once we get to GA pricing, which is kind of our target goal. And you get the dynamicness of the performance. And then once you have this pool concept or this group concept, now you've performed actions across the pool, which in this case was a setting. And so it's a place that we're beginning to invest more and more. It's very, it's funny to think about it now. It's relatively easy to think of singleton databases. It's very complex when you think of it in tens to hundreds to thousands and the operations that you would perform across those. And so it's a big place that we're investing in. It's also a big place that we have the unique ability to do because of the resources that we have and we can apply towards it. And so that's an example of that. And I was going to show one last thing before we go. And this will just show, and I'm going to do a thing here. I'm going to run this performance. This is a load generator. And basically it's for a ticket app that I'm buying a bunch of tickets on. And if you'll see it run here, I'm going against a basic database in a singleton mode. And it's going to be in the 200 to 250 transactions or purchases a second. And so I'll let that go for a minute. And that's actually using this database right here, which is, if I bring it up, you'll see that this is a basic. It's got the 5 DTUs. It's got the monitoring that it's going to go through. You'll see down here that it is a basic. And when you come up here, you'll see the load, and it's just starting to come in because this reads every 15 seconds. And if we give it a second, you'll see that it's going to spike about 100% of the utilization of that. So it's using all of its DTUs that it has capacity for. But I'm not getting the throughput that I want. So let's do a test. Let's have the same exact load generator. I've already moved this database into a pool. So again, by definition, in a pool means it can go from an S0 to an S3 dynamically. And let's see what the difference purchase rate is. Again, same app, same load generator, same database name, just one has been moved to the other. And you can see the performance difference. You're at 1,200, 1,300 purchase per second. And all that is it's just dynamically choosing what the load is that you'd want out of it. And if you're to come here, this is actually the database that's in the pool, the customer one database that's in the pool. And what will happen, and it takes a couple seconds for it to come up, you'll see its blip. And it's using about 20% of the resources to get that, which makes sense because if you do the math, it's a pool, it's about 200 DTUs, 20% of it is 40 DTUs, and yet you're getting this big performance increase that it's using. The beauty of it is that app, most of the time, would be sitting fairly idle and it wouldn't require it until I run this load generation on it. And so the reason we use this is we have a ticket application that we'll see in some of the demos that, and I don't know, Tristan, if you show that tomorrow, I think.
Parts of it, yeah.
Show that parts of tomorrow where we talk about a ticket vendor that has many venues and many artists, and then the load when they put out a concert. And one of the things that we've talked to when we talk to these people is they don't know always the demand that's going to be on ticket sales. They don't know if it's going to be a hot concert or not a hot concert. How many they're going to get per second. And so they always had to guess on what database they put on it or guess what capacity they had on it, and they would always over provision. This gives this capability of putting them in a pool, and then it just dynamically grabs what it needs. And this kind of gives you the performance that goes along with that. And the concept is, say I'm the developer, and I'm supporting this application, and I've got 1,000 customers, and I've got concerts going, and some are going way beyond expectations than the others. The last thing I want to be doing is updating that database or monitoring that. I just want to have a pool that's big enough so that it automatically handles it for me. And that's the whole concept of this, of one, to remove a burden from the app developer and the person that manages it, and then two, to put it in a very predictable budget that you can account for. And so you choose that. And so in many ways, I guess the thing I like to say is we're taking a very unpredictable world and then putting a very predictable box around it and letting it go from there. So that's the main points of that. And here you can see it shot up to about 20%. If I went back to it in its singleton mode, it was 100%. And then you see the performance difference is about 4 to 5x the performance automatic, and go from that. So the thing I would leave us with was this concept Couple things. This is in preview today. The range that we provide is what you see here below, 200 to 1,200. That's not going to be the final range. We will go lower. We'll probably start at 100 at some point, and we'll go higher as well. For preview, we're allowing up to 100 databases. That will definitely grow higher. It's just our starting point that we're going through preview. And then the other thing is, this is in the standard group. We will also have a basic and a premium elastic pool as well. And so if you can imagine those, then your premium pool goes to, P1 through P3 dynamically, and your basic pool is more on the lower end. So that way we give 3 specific price points for somebody offering. Because if you can imagine yourself, if you were delivering a SaaS app, you probably have a free trial, you probably have a bulk of your customers in this middle range, and you probably have some high-end customers. All of the 3 price points that we would provide for pools. Same concept, so you can apply them accordingly. And so I'll leave you with this just to see if this, and then we'll have questions, to see if this animation makes more sense now that what we showed. Because this is really the whole point. You're in the singleton mode. You're over-provisioning for spikes. The right column is a great example of that. Your left one's a great example of you didn't over-provision. And so things became slow. You put them in a pool. You've got the dynamicness that you don't have to worry about it anymore. And then you just control the budget based upon this maximum number of DTUs that you decide to buy. That's your budget amount, and then the databases that you put in there. And then the last thing that I would, to summarize this Torsten's point, once you do that, now you can do operations across those databases, those 30 databases, those 100 databases, those 1,000 databases when we support that. And that's the whole point of the thing, to take an unpredictable, very unpredictable environment and make it very much more predictable in a controlled manner for a budget that you can control and maintain. So that's the summary for that. I think I have just one last slide, and then we'll leave the rest for questions. And so this is the summary. We have this across the world. The thing I'd have you, if there's nothing else I'd have you remember from this, it would be we have to operate this thing at massive scale, right? We just do, and it's across the world, and it's a great example of where Microsoft is running the software that it's delivering in a very, very deep way. And this is analysis of the same sort of thing. We've got to manage millions of databases, and so this technology is the things that we'll have to use for ourselves, let alone customers that use that accordingly. And I'll also note, and we've done a lot of analysis on this, there's virtually nobody out there that handles things at more than 30 databases. Other systems begin to break down either on the financial way, or the flexibility way, or the management way. And so it's pretty groundbreaking stuff. Now this is just the token thing at the end. I guess if you put a code in, you guys probably know more about this than I do. If you put this code in, then there's some drawing that you can win and go for. So why don't we've got a few minutes for questions. If somebody can turn the light on back there.
And before we go into questions, a quick note on tomorrow's sessions as well. So tomorrow morning, I'll be doing a deep dive into the Elastic Database pool. So if that struck a chord with you today, I'd encourage you to check out that session tomorrow morning. Tomorrow afternoon, I'm doing a session on all the Elastic Database features all up. So we're going to take a look at Elastic Database Jobs, Elastic Database Query, the pools as well, and see how you would use them together as a package to make building and running SaaS applications in Azure much, much easier for you. So if that is something that is interesting to you, if you're thinking about SaaS applications, if you are a SaaS provider, I'd highly recommend that session as well.
Okay.
With that, questions would be great if you could use the microphones.
I guess they're recording it, so if you guys can come up, or we'll try to repeat it.
Maybe I'll try to talk loud. So you're going to make my life really, really easy with this notion of setting up databases, being able to provide some sort of disaster recovery by having geolocation and so on, also scaling with the pooling. The last piece that I can see that you guys could help me out with is that notion of versioning. So version 12 is fairly recent. What happens when my pool of databases at version 12 now have the opportunity to go to version 13? Are you going to do anything to help me manage that?
Yeah, we're not at version 13. But yeah, the point for us will be to try to make it as seamless as possible. In cases where we can make it where you don't even know it happens, that's what we'll do. If we can't do that, then we'll do a notification and some process that you go through. At this point, I don't even know what we would have to do. We don't have anything right now that I know is breaking going forward. So I don't foresee anything, but we will always let people know ahead of time if we're going to have a breaking change in some way, shape, or form. Yeah. Oh, you got a mic first.
Is this working? Yeah. So I just want to ask, can this be used for a SharePoint database?
For what?
For a SharePoint database. Does it have master table and?
I haven't tried this myself, so take it with a grain of salt. I don't see a reason why it should not work. The question, I think, really goes back to, are there any features that SharePoint is using that are not contained within the database? So the distinction that we're making is in terms of compatibility. We're pretty much there in terms of whatever you can do within a database and concepts that are tied to the database. What you can do on-premise, you can now do also in Azure SQL DB in the cloud with the V12 update. Now, there are other things you can do on-premise that tie back to the instance or to the server level on-premise, and those are still quite different on the cloud. Now, SharePoint has been written as an app against the on-premise version, and there I don't know what concepts from the server level they use and what would happen to them or what you would need to do for them on the cloud.
Okay, thanks.
I think it's I would recommend also stopping by the SharePoint guys in the exhibition hall. Probably that is a thought process that they already went through, and they might have guidance for you, or they can tell you up front, no, that's not going to work anytime soon.
Okay, thanks.
Was there another?
You guys, do you have any future plans or thought about offering prioritization for throttling? So say you have 10 databases in a pool, you have 9, you don't really care if they get throttled too much, or you prefer to keep that.
Yeah, we've thought about it. The thing I didn't mention, and you triggered this point for me, once you put these in the pool, you can also at any time take one out and put it into a singleton. So say you got one that was really, really hot, or you knew it was going to get hot for a period of time, a day, a couple hours, you can pull it out and put it into whatever single database you wanted, and then you can put it back in.
And it's non-disruptive to your application, so it doesn't mean an outage or downtime for Apple.
But yours is more fine-tuning what's in the pool.
Not that you know what's going to get hot, but when it does get hot, you want it to.
Yeah, we've thought about it for sure, but in this first phase is we want to get the basic mechanics of it down and then let the telemetry tell us what the normal attributes are of the systems. The customers that we've talked to and tested, they have on the order of, they get on the order of 1,000 databases, and at any point 2 or 3 will get really hot at some point. But then the others don't, and they're mild, and they fit within the patterns. But we also need more people using it. That's why the public preview, so that we can judge those things more as well. Yeah. The thing too that I wanted to touch on this stuff is everything that we showed you is live. We're just using the live bits through the wireless connection here on the portal itself. And it all went live last, was it Thursday? Wednesday? We were in San Francisco when it went live. So is our team producing it. And so it's there today. The price point's there. It's a preview pricing. It's 50% off. You can go. I just encourage people to go play with it. Create some single databases, do your test, put them in there, do your test, and go through that. And so we're working on that actively right now. Is there?
One of the great features with SQL 20 as well is that you can deploy SSIS packages to the server. What's the approach with if you have a cloud database?
I'll let you answer that.
SSIS packages. Are you? Let me make sure that I understand your question. Is your question about running the SSIS package in the cloud, or is it whether I can use cloud as a source or a target for an SSIS package?
Well, if I have an SSIS package that needs to move data from one database to another,
Yep.
and they're both there, and I just need that package to move it. So where would I run the package?
So that's a great question. I mean, you can define a package that has Azure SQL DB databases as source or as a target. However, right now we don't have a cloud-hosted service for SSIS per se. So one way you could go with that is spin up a VM in infrastructure as a service, just in Azure proper. And then you have a machine and the compute, and you can even take one of the pre-canned ones from the gallery that have SQL Server installed, so you'll find SSIS on those. And then you can run that for the time that you need to process that package. So that would be one way. The other option that I see is SQLDB has an import-export service that you can use as well. If the granularity for you is, for instance, exporting a whole database, you can do that using that service. Basically export all the data in that database, put it into Azure Blob Storage, and pick it up from there and import it into whatever target database you want it to be. So those are really the two options that I see.
I had a question around pricing. You say the structure allows you to take unpredictable jobs and make them more predictable. Is the pricing predictable when you move up to the singleton tier?
Yeah, it's all, we do it's effectively you do a charge per DTU, right? So the basic tier has a price for DTUs. The standard tier has a different price for DTUs in its range, but it's consistent across the range. And then the premium has a consistent price for its tiers. So I think somebody like if you had 10 DTUs and you're buying that, and then you had another one was 20, then it's going to be twice as much. So it's very rational that way. Now to be specific on the pools, they have a different price for DTUs because we call them elastic DTUs because they kind of shift around. So they have a different price. So the standard one has a price, the basic one will have a price, and the premium will have a price as well. And it's all up on the pricing page right now, by the way, as well. So if you guys go out to Azure.com, go to SQLDB, pricing page will have the singleton pricing, and then they'll have the preview pricing for the standard pool. And then the documentation's been updated out there for these concepts as well. So there's basically, I always think of it, let's see if I can just show you real quick. I think I have it right here.
You're in 6.
I'm 8.
Oh, you're 8.
Yeah. So if you go to SQL database, it's coming up.
8. You're disconnected.
Oh, that will help. So if you come here, this is the overview page for SQL database. I always say there's these 3 links that really is where all the information is: pricing page and documentation, and then what's down here. So you'll see talking about building SaaS applications, and then the link to the pools. But if you come to the pricing page, and we have 2 different models. Here's your single database view, so basic, and I think this kind of tackles your question that you had here, S0, S1, S2, S3. It gives a different price associated with the DTUs. And so an S1 is twice as much as an S0, so the price is twice as much. The performance or the resources are twice as much. And the premium's below. And then if you go back up to the top, you'll have the toggle for the elastic database pricing, which we just have the standard pool right now, but it gives the attributes of that. And the other thing, these are things that are billed on hourly, so it's billed per hour as well.
Yeah, I have a follow-up. Is it related to the availability of that server or the actual usage of the server? So if I have a database that's probably overused,
Yeah. So it's the creation of it. So if you create the database, then it's billed for every hour that it's there in existence, right? And that's why you see some companies will create temporary databases, do some work, and then drop them. But it's billed by the hour that it's created. The pool is the same way. The pool is a reservation. You're reserving this amount of space, and you can make sense. Say you wanted 1,000 DTUs, right? Well, on our side, that's a fair amount of hardware that we're guaranteeing you. So whether you use them or not isn't our concern because we've reserved it for you, and so it's charged accordingly. And that's why we provide so much data so that you can grow or shrink it to the size that makes sense for you, that you want to tackle. Did that answer your questions? Okay. Anything? Yes?
So charging is based on hour, that doesn't mean business hours
You, you could have it. I'll use your example. You could have a P2 during the day, and then go to a you could do that. It's also where the pool sometimes comes into effect. Depending upon how many databases you have, may be a better route to tackle that as well. What we find is customers do a mix of, they have some databases that are heavily used during the day and some that are heavily used at night, right? And so those, you can actually leverage a pool to give you a better option for that. But yeah, there's nothing to stop you from saying, have a script at 5 o'clock every day to take something from a P2 down to a P1 or what have you, and then come back. We just have to be, the only thing you have to be careful of is the premiums have more storage than the standards. So you have to make sure that you're not going down to a place that doesn't have enough storage to serve your needs. Two, some of the replication has more advanced features on the premiums right now. So you have to be careful if you go down that you don't lose that functionality, right? So there's just some of the mechanics of it, but in general what you're saying is possible. Yes, sir. Well, that's. I'm afraid you're leading me somewhere. I don't know. What do you mean by that? You have a subscription, you pick your databases, and you pay that way. Now you can have an EA agreement that is just a quota that it reads against, or you can be a pay-as-you-go, which is on a credit card and charges you that way. But
so I think the question really is that for a SQL database, do I need to have a SQL license in addition to charge?
No, you don't.
Nope. This is all there is. Yeah. Yes, sir.
Have you ever calculated a break even on, like, if you need a persistent database and you can't drop it and bring it back to Azure, we're going to break even to see this versus, let's say, IANS, bring your own SQL license. Where's the trade-off?
Yeah, so I haven't done that analysis. In general, this is less expensive. Just across the board, this will be less expensive.
But if you're paying by the hour at some point, it may not be less expensive.
Well, you pay both by the
Yeah,
hour.
yeah.
Right? So the VM and IaaS is also billed by the hour.
Yeah, they're by the hour as well, and they're a higher rate by the hour.
The thing that I would look at is particularly features around manageability. How much time and effort would it take you on a VM to get to the same level of service that you would get right out of the box without any effort through SQL DB? So just think about the 4 nines that you're getting right out of the box. In order to implement that on VMs in Azure, there's a substantial amount of work involved in that.
Yeah, I always go back to, do you want to go back to managing patches again? That's just the most simple one I think of. Do you want to go back to doing that? And I mean, there's organizations that have whole staffs that's what they think about. And I guess you could say we have staffs to think about that. But this takes that part away. So that's the difference. The difference in it. And I know, and I get asked all the time of, hey, give me the price difference between this and that, and they're kind of apples and oranges, in a sense, once you get going. But I think it's a good question. Anything one?
Can you turn it off but retain it and turn it on later and save money that way?
No.
What do you mean with turning things off? Turn a database off?
Yeah, can you just sort of stop that service temporarily? Like say it's a development system and you're only developing a few hours a day or something. You don't want to run it all the time.
Yeah, you don't.
You could restore from a backup.
You could, yeah. I was going to say, at the end of the day, you have to delete the database to not be charged for it.
Yeah.
Torsten's point is you could back it up and have a backup sitting there, and then start up a new database and bring it back in. But I think when you look at the prices, it's kind of pennies. It's kind of pennies on the day, depending upon which one you're dealing with. And that's also why the pool helps in some ways, because depending upon how your development cycle works, you can have certain ones be used heavy at one point of the day and other ones used at other points of the day, and you can balance it out that way.
So rather than deleting the database or deleting the service, I would think about, can you aggressively schedule it down into the lower performance tiers, lower performance levels, where the price point is just much more attractive, and then you don't have to go through that many hoops and hassle.
Okay.
Like pools were founded by a server, right?
Not yet. But yeah, not yet. But again, it's in the preview right now. But that's the thing that we have to look at. Our ultimate goal at one point is to have thousands and thousands of databases in a pool. And so when you think about that's going to cross over a number of things. But we're going through the first iteration right now. And the common case we're finding is I can name all day people that have thousands of databases and go through that, but I can also name the majority of SaaS app providers and stuff have less than 100, right? And so we're trying to get the sweet spots first and mechanics from there. Okay, good. Oh.
So my system has a lot of databases that were on pre-SQL 12.
Okay.
Are there any things I should watch out for, any gotchas, if I pull those up to SQL 12, if I upgrade those?
I don't think so. In fact, I would
Be
argue
prepared for better performance.
Yeah. Yeah, I would. Well, wait a minute. We should be. Let me make sure I understood your question. So, are you saying that the databases you have are SQL DB databases that are pre V12?
Yes.
Oh, okay.
Yes.
Okay.
Azure SQL DBs pre V12.
And are they additions? So are they basic, standard, blah blah blah, or are they web and business?
I've got a couple of legacy web and businesses around, but most of them are basic or standard.
Okay. Yeah. So no, you won't. You only get better because the performance is going to be better on them. Particularly when if they're premiums, particularly there, the performance will be better. And then also the S3 that you saw that I showed doesn't exist in the version before. That's only on V12. So that gives you that angle. Okay. Okay. Thank you, guys.
Thank you.